All right, everyone. So here I am at my parents' house, and I'm looking at this giant map they have on a wall right there. And then while I was looking at that, I was looking at this globe that's right here. And I'm sitting there thinking, how can that possibly be? Like I look at this, and I'm like, how could this possibly get on that flat surface? So then I started thinking, how could I break it? How could I figure out a way to solve this problem? And so first I thought a hammer. And then I was going to go smash this, and my mom was like, you can't smash that globe. It's old, it's important. And I looked at it and I went, no, that's kind of lame. Okay, fine. So globe goes away for right now. Then I started thinking, what's the same shape, sphere? You can tell there's a cutting board here to protect this table. A tennis ball. So then I was like, okay, let's see if this is going to work. And then my mom was like, you're going to break your finger. And I'm like, Mom, why are you watching me teach lessons? That's weird, but whatever. So she said, no hammer. Fine, okay. This, maybe I can like, no, that won't work either. How about a chainsaw? I think that might work. No, but I think this might be too loud is my issue. So we're not going to use that. So instead, I went with just like a serrated knife. Being very careful, I started thinking, okay, how's this going to work? So start cutting into it. Now, this would be easier if it was like an orange or something, but all I had was a tennis ball. Okay, so now I have a tennis ball split in half, just like a sphere, just like the globe, right? Just like our world. And I'm looking at this, and I'm like, okay, so I'm just going to try and smash it down. Maybe I need the hammer. Okay, so no amount of smashing would work on that. So how am I possibly going to get this flat? So like maybe if I cut some gaps. So I'll show that in a second. I'm going to start cutting. All right, so about 10 seconds later, I have the tennis ball that I haven't cut, and you can't make it flat. There's no way I can push this flat except breaking it apparently. And then I have this tennis ball that I can push down flat like that, which is basically now we're starting to get closer to what a map looks like, right? But you don't want to have a map that has all these like ugly cutout parts. And so what they actually do with maps to get them from a sphere to a flat map that looks like that is they just stretch the parts to fill in the gaps. And so that works out great until you realize that it stretches stuff and makes stuff look really, really weird. For example, look at the shape of Greenland up there. You see how it's kind of like just almost like a square? And then if you look at Greenland, I'll leave it up there so you can see Greenland's the purple one at the very top. And then if you look at Greenland on a globe, look at the shape of Greenland on the globe. It's a totally, totally different shape because the stuff at the poles, the North Pole and the South Pole, on a flat map are the parts that get stretched, as we just laid out on this tennis ball. That's what you have to do to make it into a square, nice map, is you stretch it. You stretch these parts to fill in the gap in the middle. I'll show you one more time. And so you'd have to stretch like this part to fill it in. Now, I'm going to make the argument, you don't have to agree with me, but I'm going to make the argument that if you look at maps, there's a very specific part of the world that gets stretched. Hint, hint, it's like Europe and the northern part of the map. And I'm going to make the argument, once again, you don't have to agree with me, that there's a reason why that happens. And want to take a guess as to where the most common maps that you see in classrooms all the time come from? Hey, they were originally designed in Germany and other parts of Europe, which is why that part of the world is one of the ones that gets stretched to look bigger, stronger, more powerful, in my opinion. You don't have to agree. There's an awesome website called truesize.org that I'm going to show you right now. Check this out. All right, so check this out. The website's actually called thetruesize.com. And if you take this little box up here and write in United States, you can take the size that the United States looks like on flat maps. And then what's fun about it is that this website allows you to drag it around so you can see what the actual size of the United States is compared to other countries. And so the United States is certainly bigger than India, but it's not as much bigger as you would think it is. If you drag it down towards the equator, the United States is somewhere close to the same size as Brazil, even though if you look at the maps that you see in classrooms, you'd think the United States is much, much, much bigger. Let's do a more fun one. Let's take Greenland, which is my example because it gets stretched more than any other landmass on the Earth when you look at modern day maps. And let's just take Greenland and let's drag it all the way over here. And you should be able to see just how small it's actually getting as we get to the equator, which is the part of the world that on modern flat maps doesn't get stretched. Greenland looks giant, massive, huge on our paper maps that we look at every single day in classrooms, but it's actually much, much, much smaller. On most of the maps that you've seen in classrooms, Greenland looks as big or even bigger than Australia in real life. Greenland is about 1/3 the size of Australia. And so you've been lied to your entire life by these maps in classrooms. You've been lied to based on the size of each country and each landmass, and even the shape of those land masses. Because look at Greenland here compared to there. It's a totally different shape. And so my point is, that doesn't happen by accident. I'm going to make the argument that the northern part of the world, the part that gets stretched on all of these maps, set it up like that on purpose so that you would immediately think that they're bigger, stronger, more powerful. And you'll have to see if you agree with that hypothesis as the class goes on. But all I have to do is show you Greenland and look at how much it gets stretched, or even the United States, or even like a country like Germany. You can see it right there in the middle of Europe. And even though it doesn't get stretched like Greenland gets stretched way up here, if you take Germany and you start dragging it towards the equator, it gets much, much, much smaller. And so I would argue there's countries that have vested interest in making sure that you have maps that look like this because it makes them look stronger, more powerful. Now your job is to go knock out that Flipgrid assignment where you somehow in your house explain why maps get stretched and have some fun with it. You could even include, if you really want to, hammers and spatulas and knives, but be very careful. I'm not responsible if something bad happens, or even miniature fake chainsaws. Knock out your Flipgrid assignment and have a good day. Bye, everyone. Oops, I forgot one thing. When talking about those countries trying to make themselves seem bigger, more powerful historically, I want to bring up that story about my grandparents and him pulling her by her hair out of the ocean. I was always told the romantic, like their eyes met, that story, because it made my grandparents look better. The actual story of him pulling her out of the ocean by her hair is slightly different, and it casts them in a different light. And so I'm not trying to attack or say those countries are bad because they get stretched on a map that was designed 400 years ago. That's ridiculous, but it's something that you have to be aware of. Knock out that Flipgrid assignment, have fun with it.